Hello student, welcome to our physics discussion, that is physics in a start way. We were with the so-called Newton's law and we were discussing first law, and as we have discussed, you may say this advice to you is that as because these laws are fundamental laws, one needs to contemplate a lot on those laws. Just going through superficially Newton's first law and thinking that I have understood it and all those things may not satisfy the cause. So that requires a contemplation. And as we are doing, we are trying to contemplate it in a slightly different way. That was trying to find out the things that Newton's first law conveys to us. Those are implications of first law. And so far, implications of first law as they are. Already we have started to discuss it. The first was the definition of the force. The definition of the force. Definition of the force. Second implication was the property of inertia. The property of inertia. There we are discussing that everybody mass is associated, or there is a common property which is associated with any mass that is known as inertia. It can take a sort of laziness. Like the third implication and the last one here will be that is idea on the reference frame or frames of reference. Frame of reference. If somebody wants to cut the long story short, the frame of reference can be very simply replaced by a word that is observer. Observer, we know. We are using this word since the start of our physics. We may be discussing motion or all that, using the words just like a body starts with an initial velocity. It is as if somebody is describing. So everywhere, usually in almost more than 90% of cases, we can have a frame of reference and an observer. A set of observation is taken from the point of view of an observer. And when we say an observer, we are not here to observe or to measure the smartness or handsomeness or beauty or mental acumen and all that. Our observer must be a scientific observer. So far as scientific observer is there, it must have certain properties. And that observer is known as a reference frame. You can use the word observer or you can use the word frame of reference. The first of all, to measure the position and all that, our observer must be having a set of XYZ system or XYZ coordinate system. That is the first requirement. Second, our observer must be conversant with the so-called physical quantities it is observing. And third, the observer must be having a way to measure time using a stopwatch or whatever it is. Okay. But only defining that way, our idea on the reference frame or observer is not complete. Is not complete as the first law, so-called Newton's first law, it points out one thing, of course, that remains hidden, and if it is unraveled, then that claims that Newton's laws are valid from the point of view of inertial reference frame or inertial observer. It divides the entire observer into two categories. Let me remove it. It divides the entire set of observers into two categories. First of all, a part of observer that is known as, or it can be taken as inertial or inertial reference frame. I am writing in short. Second set of observer is non-inertial. It's non-inertial. Non-inertial, we may say that is a reference frame or observer. And as per Newton's claim is that Newton's law is valid only for inertial reference frame, is not valid for the so-called non-inertial reference frame. Or if the observer qualifies in the first part, that is inertial reference frame or inertial observer, then he or she will be seeing or measuring the Newton's law or anything associated with Newton's law correctly. If the observer is non-inertial reference, if the observer is of non-inertial type, then he or she will measure everything wrong or Newton's law will be valid for him or for her. So now we have to go to the meaning or the sense of inertial observer or inertial reference frame. An inertial reference frame is a reference frame. In fact, if we go into it in a detailed way, that becomes a very long issue. So to cut the long story short, we do one thing. We can brand an inertial reference frame as the reference frame which doesn't accelerate with respect to the surface of the Earth. An inertial reference frame is the reference frame which doesn't accelerate with respect to the surface of the Earth. We know our laboratory, any observation, any scientific setup will be there in our laboratory, and our laboratory is usually 99.9% is on the Earth. So thereby, if the observer who observes the thing, it doesn't accelerate, doesn't run with an acceleration on the Earth's surface, that is known as inertial reference frame. If he or she has a velocity or moves with a velocity and that velocity is constant, the Newton has got no issue with it. You have to understand. Because we know, as per Newton's law, the body may be at rest, the body may be with a uniform motion. In both the cases, no force acts on it. So both the states are same, so far as force is concerned, and so far as Newton is there. Okay, so an inertial reference frame is a reference frame or is an observer which either at rest on the surface of the Earth, or if he or she is moving, he or she is free to move, but with a constant velocity, means with a fixed magnitude of speed in a specific direction. And a non-inertial reference frame is a reference frame which oscillates with respect to the surface of the Earth. In fact, speaking truly, if you take the things to a broader scale, we cannot find in the entire universe, we cannot find the single observer, single reference frame which can be branded as inertial, which we can guarantee as inertial. But at present, we should not attach ourselves, we should not go into those issues, or else we will be getting mad, because we are kids and our observation is limited. We have just started to learn the Newton's law, so we do not go into all those issues. So we now brand that inertial reference frame is a reference frame or an observer which is not oscillating with respect to the surface of the Earth. That means it is either at rest or moving with a constant velocity. And non-inertial reference frame is an observer or is a reference frame which oscillates with respect to the surface of that. It is accelerating on the surface of that. And from that reference frame, if any observation regarding forces, mass, motion is there, that may be coming out incorrect. That was the deduction of Newton, or that is the implication, third implication of Newton's first law. Okay, so that's all about the Newton's first law. Let us go to the second law. That will be going in the next video. So thank you for your patience. Thank you for your patience. We shall be going in the next.